In this presentation, I am going to explain the previous gate questions and answers of the year 2025, and the topic covered is analog electronics. Now let us see the first question of 2025 gate question that carries 1 mark. First question is, which of the following statement is true about the small signal voltage gain of a MOSFET based single stage amplifier? The options are A. Common source and common gate amplifiers are both inverting amplifiers. Option B is common source and common gate amplifiers are both non-inverting amplifiers. Option C, common source amplifier is inverting and common gate amplifier is non-inverting amplifier. And D is common source amplifier is non-inverting and common gate amplifier is inverting. Therefore, these are the 4 options, and the answer is option C, that is common source amplifier is inverting and common gate amplifier is non-inverting amplifier. Now let us see the circuit diagram of common source amplifier. The common source amplifier circuit diagram in which source is common to input and output, or we are giving the input between gate and source and output is taken between drain and source. So source is common to input and output, in which we can see that one, the phase relation between the input and output. Here output voltage or the output signal is 180 degree shifted of the input signal. There is an this is the output is getting inverted with respect to the input. Now this is for a common source amplifier, and for a common gate amplifier in which the gate is common to input and output, because you are applying the input between source and gate and output is taken between drain and gate, or gate is common to input and output, in which the phase relation between output voltage and input voltage, they are in phase, or there are 0 phase shift is there. Therefore they are in phase. Therefore common gate amplifier, it is a non-inverting amplifier, and common source amplifier is an inverting amplifier. Therefore answer is option C. Now continuing the same problem. Here this is the common source amplifier circuit diagram, in which we have already explained the phase relation between output and input. They are 180 degree out of phase, and the 180 degree phase shift is a key characteristic of a common source amplifier. And when the input voltage increases, it increases the current flowing through the MOSFET, or when input voltage increases, the input gate current increases. As gate input current increases, the drain current increases, and which in turn increases the voltage drop of the drain resistance. As the drain current increases, this drop increases, or the voltage at the drain point gets reduced, and leading to a decrease in the output voltage, meaning that when the input voltage increases, the gate current increases or drain current increases, this drop increases, the output voltage at the drain point reduces, or the output voltage reduces. Therefore, there is a 180 degree phase shift between the input voltage and the output voltage in the case of a common source amplifier. But in a common gate amplifier, the output signal is in phase with the input signal. This means that when the input voltage increases, the output voltage also increases, and when the input voltage decreases, the output voltage decreases. Therefore, there is an in phase relation for the output voltage and input voltage for a common gate amplifier, and there is a 180 degree phase shift for a common source amplifier. Therefore, the common source amplifier is an inverting amplifier and common gate amplifier is a non-inverting amplifier. Now let us see the second problem of 2025 gate question that also carries 1 mark. Assuming ideal op amp, the circuit represent is, that is, this is a circuit. What does it circuit? The options are option A, summing amplifier, B, difference in amplifier, C, logarithmic amplifier, and D is buffer. Now this is a circuit to be considered here. There are 2 op amps here. Now let us see the input is applied at this point and output is available at this point. Now coming to this first op amp, since we are applying an input voltage at this point V in, because of the virtual short circuit, you can say that this voltage is same as this voltage. Therefore, this point voltage is same as the input voltage. And coming to this op amp here, this is the output voltage, and because of the virtual short circuit, this voltage is same as this voltage. or non-inverting voltage or inverting voltage and non-inverting voltage are equal. But this voltage is same as the V out voltage. Now this V out is same as the V input voltage, meaning that the output voltage equal to V in the input voltage V in, or this is working as a buffer. For the option is answer is D. It's a buffer. This is a buffer circuit. Now let us see the third question of 2025 gate question that also carries 1 mark. The IV characteristics of the elements between the nodes X and Y is the best depicted. That is, this is a element in which there is a constant current source, and across that there is a resistance is a 1 kilo ohm, and this is the terminal is X, this is the terminal is Y, and the current through this one equal to IXY, and the voltage across X and Y equal to VXY. Now what is the relation between VXY versus IXY? VXY is taken on the x-axis and IXY is taken on the y-axis. Now if you see the voltage across the point X and Y, or VXY, is equal to the drop across the resistance 1 ohm resistance, which is equal to, for the current through this one is given by IXY minus this 1 ampere. IXY minus 1 ampere is the current through the resistance that into the resistance 1 kilo ohm. Therefore IXY minus 1 into 1 kilo ohm, that is the voltage across this point VXY. Or rearranging this one, IXY equal to VXY divided by 1 kilo ohm plus 1. Or this is similar to the equation y equal to mx plus c, in which IXY can be considered as, say, y-axis parameter, and VXY is taken as the x-axis. Therefore y equal to mx plus c, comparing to that one, m is the slope, which is equal to 1 by 1k. M equal to 1 by 1k, and the y-intercept equal to z is the y-intercept, which is equal to 1. Therefore this is the equation relating the current through this one and the voltage across this one, which is equal to VXY divided by 1k plus 1, and this is represented by the option. This has got the y-intercept and the slope of this one equal to 1 by 1k. Therefore the answer is option B. Now let us see the fourth question of 2025 gate question that also carries 1 mark. In the circuit shown below, if the value of R and C are very large, the form of the output voltage for a high frequency square wave input is best represented by, suppose this is a circuit, resistance and the capacitance, and this is a square wave, high frequency input is square wave is applied here. Now what is the output voltage waveform? Out of these 4 choices, let us see that one. Now for this output voltage, this is something like this, an integrator. We are taking the output across the capacitor. Now if you write the output voltage equation V0, that is equal to, which is equal to 1 by RC integral of this input voltage, integral 0 to t by 2 the input voltage V in dt, and input voltage equal to 1 volt. Therefore integral 0 to t by 2, 1 by RC integral 0 to t by 2 1 into dt, or t by 2 RC. Therefore t by 2 RC is the output voltage equation. But already we see that one, resistance and capacitance, the RC are very large, and since the frequency is very large, the T will be very small. Therefore T will be very small and RC will be very large, meaning that this quantity will be always, this will be, this quantity will be less than 1 volt. Therefore the V out equal to less than 1 volt, since the time period T is very much less than the time constant RC. Therefore the output, the answer is, looking to this waveform, you can see that one. This is the integrate. This is actually differential output, but since it is an integrate, we can see that this is the integrator output, and the magnitude of that one should be always less than 1, since the T is very less compared to the time constant RC. Therefore the answer is option C. Now let us see the fifth problem of 2025 gate question that carry 2 marks. The op amps in the following circuits are ideal. The voltage gain of the circuit is dash. Round off to the nearest integer. Therefore, this is the what is the gain of the circuit? That's the question. The 2 op amps are there. This marked as this, which is marking, we are marking it as A1 and A2. This is taken as A1 and this is A2. And this is the output voltage and this is the input voltage. Now this input voltage plus polarity here, minus polarity is here. I am drawing the same circuit like this one. Here this is marked as A1 and this is marked as A2. and this voltage I'm marking it as V2 and this voltage marking as V1, so that this is a plus point and this is a minus point, or V2 minus V1 equal to the input voltage Vin, or Vin equal to V2 minus V1. V2 minus V1 is the input voltage and V out voltage is there. Now coming to this one, this is the op-amp A1, this voltage equal to V1, and since this is a by virtual short circuit here, this same voltage as this V1, or this circuit is same as a non-inverting amplifier. This circuit is a non-inverting amplifier in which the output voltage Vx equal to the basic equation equal to 1 plus Rf by R1 into the input voltage, or Vx equal to 1 plus the voltage Vx equal to 1 plus Rf 10 kilo ohm divided by 10 kilo ohm into the input voltage V1, which is equal to 2 times V1, or therefore the voltage Vx equal to 2 times V1. Now continuing the same problem, op-amp 1 we already seen, Vx equal to the voltage at this point, Vx equal to 1 plus 10k divided by 10k into V1, or 2 times V1, that is marked as equation 1. Now coming to the second op-amp A2 here, and since this is a voltage Vx and this voltage is marked as V2 because this is the voltage V2, and since due to the virtual short circuit this voltage is same as this voltage, or this voltage is equal to same as this voltage, or this is equal to V2. Suppose you are applying a Kirchhoff's current law to this node, then this input current equal to Vx minus V2 divided by 10k. Vx minus V2 divided by 10k. That's equal to, since the input impedance of the op-amp is infinity, the input current is equal to 0, or whatever the current coming here that will be going through this circuit, or that current equal to, it is equal to V2 minus V out divided by 10k. V2 minus V out divided by 10k. For op-amp, our input current is equal to op-amp input current is 0 because input impedance is infinite. Ideal case. Therefore, here rearranging this one, we can get that Vx equal to the voltage at this point, Vx equal to 2V2 minus V out. 2V2 minus V out. Therefore, equating the equation 1 and 2, we can get 2V1 equal to 2V2 minus V out, or V out equal to 2 times V2 minus V1, or which is equal to 2 times V in, or output voltage equal to 2 times V in, or the voltage gain equal to V out divided by V in, which is equal to 2. Therefore, the answer of this problem is the gain of this total system, that is equal to 2. Therefore, V out divided by V in equal to 2.